Welcome to our poster. I'm Tim Trammell, a third-year PhD student in Tamara Schwab's and Matt Traxler's lab at UC Davis, and this poster presents work that I did in collaboration with Natalia, a PhD student at Johns Hopkins University. Our lab has recently been interested in applying machine learning methods to decode EEG signals to study language comprehension. EEG decoding methods have been used in several fields of cognitive neuroscience, and a variety of different machine learning classifiers have been used to perform that decoding. But how do we know if we are using the best classifier for the job? In this study, we tested the performance of 3 classification models: support vector machines, discriminant function analysis, and random forests. We asked if each classifier could reliably decode the EEG signal from 2 word pair paradigms and which of the classifiers performs best throughout the time course. Here you can see 2 word pair paradigms that generated these datasets. In the first paradigm, participants were shown a prime word and asked to try to actively predict the upcoming target word. Some of the word pairs were related and some were not. For example, the participant might see circus followed by clown, but they may instead see table followed by clown. The related word pairs had forward association strength to lead to about a 50% accurate prediction rate. This paradigm produced 3 plausible decoding conditions: predicted related versus unpredicted related. And this would be a case like circus clown and the participant successfully predicted clown versus circus clown and the target indicates an unsuccessful prediction. And this isolates prediction effects by holding relatedness constant. Next, we have unpredicted related versus unpredicted unrelated. And this would be circus clown with a failed prediction versus table clown with a failed prediction. This condition isolated semantic relationship effects by holding prediction constant. And finally, we have predicted related versus unpredicted unrelated. And this would be circus clown with a successful prediction versus table clown with a failed prediction. And this condition includes prediction effects, semantic relatedness effects, and any interactions between those. In the second paradigm, the participants were shown word pairs and asked whether the target word was related to the prime word or not. This resulted in a single decoding condition of related word pairs versus unrelated word pairs. In the related word pairs, all the prime words had strong forward association to the target words. We applied a decoding technique adapted from Bay and Luck to each of these conditions, holding the procedure constant except for the classifier used. We assessed each classifier using both average trial data, as used in Bay and Luck's study, and using single trials without averaging. And what we found is that all 3 classification models can decode the EEG signal for prediction accuracy and/or semantic relatedness at significantly above chance levels. And they can do so using either dataset and using either averaged or single trial data. Here we show visualizations of the model comparisons using an ANOVA-based cluster permutation test, and this shows that SVMs are consistently a top performer out of the 3 models, regardless of the data set or whether we used averaged or single trials. For those interested in details of our results, here we have tables which break down the different analyses that we performed. These tables break down the significant clusters for each model in each condition for chance level comparisons, for our initial ANOVA-based model comparison, and for pairwise t-test-based cluster permutation tests for direct comparisons between the model pairs. Based on these model performance comparisons, we concluded that the SVM-based classifier is the best suited for binary classification of accurate prediction and semantic relatedness from EEG signals. I would like to thank you for taking the time to visit our poster. Please feel free to email with any questions or to visit us during our poster session E. Enjoy the rest of the conference.